Inspection of transducers after system setup. The difficulty of transducer inspection after system setup is the absence of a proper reference. In many cases, this can be overcome with the help of a model-based approach. Nevertheless, in this application, a whole batch of transducers as a reference within the batch is used. Building the mean correlation coefficient for all combinations of all transducers, except a single one, and subtracting the mean correlation coefficient of all transducers with a single one from this value. This can be used as an indicator for the similarity of the single one with the whole batch. Another procedure without using a reference is described in, the use of correlation blocks is suggested in. In this application, 16 transducers have been mounted on a plate structure. The plate has been contaminated with wax at two positions so that PUS 12 and 16 are insufficiently bonded. Using the correlation coefficients of all combinations, the two contaminated PUS could be clearly identified, c, showing significantly higher indicator values than the rest of the sensors. Damage indices, based on the comparison of correlation coefficients for all 16 PUS after system setup. PUS 12 and 16 are insufficiently bonded due to contamination with wax. Inspection of transducers under changing temperature conditions. The influence of environmental and operational conditions is known to be non-negligible for the automated continuous monitoring of structures in general. The effect on the inspection of piezoelectric transducers using the EMI spectrum therefore needs to be considered. In this application scenario, a model-based and a purely data-based method are used for the detection of degradation faults within a temperature range of 20 to 85 degrees Celsius. As defect, a degradation of the adhesive as well as of the piezoelectric material was introduced to a PUS by heat exposure for 32 hours at 130 degrees Celsius. 14 measurements, equally distributed over the whole temperature range, have been used as reference data for the data-based approach to train the model for the model-based approach. 26 measurements distributed over the whole temperature range are used as test data and 42 measurements over the whole temperature range have been recorded after degradation took place. Shows the results for the model and database methods in, B, and, C, as well as the temperature present during the specific EMI measurement in, A. Temperature, B. Demodeland, C. DIC for several measurements of a single transducer before and after degradation of adhesive and piezoelectric material. Both methods clearly distinguish between the degraded and the healthy state. The results show that the model fits best for medium temperatures, although the whole temperature range was used for training. The model-based approach allows to waive the explicit use of the temperature information after the training is completed. The data-based approach employing the correlation coefficient needs the temperature information to select the correct baseline. For more information on the experimental setup and the estimated model parameters, see, on the data-based method, see.